The key to understanding the eclipses the way we see them is to remember that the moon's orbital plane is at an angle of about 5 degrees with respect to the ecliptic. So let me draw this diagram again. Here is the sun, part of the Earth's orbit around the sun. Here is the Earth. And then the moon's orbit around the Earth. And the angle between the orbital plane of the moon and the ecliptic is about 5 degrees. Okay, so it takes a moon 1 month to make a complete revolution, which means then that for about half of the month, the moon is above the ecliptic, and for the remaining half, it is below the ecliptic. The points where the moon's orbit passes through the ecliptic, these 2 points, are called nodes. Okay, so here is one node N, and the second node, which I'm going to denote with N prime. Okay, so here is the ecliptic, the Earth's orbital plane, this biggest oval here, and then the moon's orbit around it at an angle of 5.5 degrees with respect to the ecliptic. And here are the nodes, right? And the line connecting the 2 nodes, the 2 points where the moon passes through the plane of the ecliptic, when that line points to the sun, the eclipses are possible, right? For instance, here, the line of nodes is not pointing towards the sun. So what happens is that when the moon is at this location, its shadow misses the Earth, right? And therefore, it's not possible to observe the solar eclipse. By the same token, it's not possible to have lunar eclipse because when we have this configuration here, then the Earth's shadow misses the moon when it is full moon, and therefore we cannot have the lunar eclipse. The eclipses happen when either solar eclipse when the moon casts the shadow on Earth, or when the Earth casts the shadow on the moon, lunar eclipse. The same is the situation here. The line of nodes is not pointing towards the sun. So again, when the moon is new, that is when it is between the sun and the Earth, its shadow misses the Earth. Okay? So it's not possible to get the solar eclipse. Also, when the moon is full, right, the Earth's shadow misses the moon, and therefore we cannot have the lunar eclipse. But when the line of nodes points to the sun, then we can have the eclipses. For instance, here, the line of nodes points to the sun, and when it is the new moon, when the moon is between the sun and the Earth, it will cast the shadow somewhere on the Earth. It turns out that complete shadow created by the moon, as we'll discuss in a moment, is only 269 kilometers wide. So you cannot see the solar eclipse everywhere on the Earth. It's limited to a region of diameter of about 270 kilometers, which is quite small, right, compared to the size of the Earth. And again, when it is the full moon, when now the Earth is between the moon and the sun, then it casts shadow over the moon and we observe the lunar eclipse. Okay, the same here. Again, the line of nodes points to the sun. At the new moon, when the moon is between the sun and the Earth, it casts the shadow on the Earth. So somewhere on the Earth, we can see the total solar eclipse. And 2 weeks later, when it is the full moon, when the Earth is between the moon and the sun, then it casts the shadow over the moon and the lunar eclipse is possible. So in 2013, there was a lunar eclipse. The lunar eclipse occurred on April 25th. And then there was a solar eclipse on May the 10th. Also, there will be a lunar eclipse on October 18th. And then there is a solar eclipse on November 3rd. So you can see that, for instance, the interval of time between these two eclipses, first pair, lunar, solar, is about 2 weeks, 15 days, right? And the same is true here. Now, the important thing to realize is that over a period of time, the lunar orbit keeps nearly the same direction in space, as illustrated on this diagram here. So as the Earth revolves around the sun during the year, as you can see that the orientation of the moon's orbital plane stays approximately the same relative to the stars. As a consequence, often we'll have 4 eclipses during the year, right? Because in that case, the times when the line of nodes passes through the sun are only these 2, right? Only here and here the line of nodes passes through the sun. For the rest of the Earth's orbit around the sun, that's not the case. The line of nodes is not pointing towards the sun. So because of this near constancy in the orientation of the moon's orbital plane, generally there will be 2 lunar eclipses during the year and 2 solar eclipses during the year. Here's the Earth's orbit, the Earth, but now the moon's orbit was in the plane of the ecliptic. There's no angle, right? So here's the moon and the Earth. How often would we have, in that case, solar eclipse and the lunar eclipse? Every month, during a month, when it's new moon, then the moon would be located here. It would be casting shadow on the Earth. And 2 weeks later, the Earth would be casting shadow over the moon, and we would have lunar eclipse. So if that was the case, we would have eclipses, both lunar and solar, every month.